Hi, in today's video we are talking probably the last time about earthing and bonding within an electrical system when you add a solar inverter. For that I have made a few drawings and we will talk about three different earthing systems and how integrate a solar system into a already existing grid-tied electrical system, which you might have the plan to do so. My name is Roland. On my channel we are typically talking about solar systems, battery storage, some small electronic projects and DIY. For this video I have to make a disclaimer. Electrical systems are very individual. My house is different than your house. When it comes to earthing systems, it's a very different scenario in different locations. Codes can be different. There's a lot of things to consider. In many places there's many things underneath the ground, inside the ground. So if you really don't know how to tackle your system, please get your advice of a local electrician and they will help you out. So whatever we are talking about today, you can only see this as a guidance. I will show you the different earthing systems. You have to find out which one you have in your place, and then you can just use this information as an extra input so that you can find out the best solution for you. Okay, enough said to this. Let's take a look what I have prepared and what we can take out of this. Right, when it comes to earthing systems, we are talking essentially of four different systems. One we have already seen in the last video, and this is the IT system. The IT system is not really used in the housing installation because one source of power is only providing the energy for one device, and this is an isolated system. We have three systems remaining, which are the TNC System, the TNS System and the TT System. And you also have to know that these are the names set by the International Electrical Association, and the naming could be a little bit different in different regions of the world. But essentially it will always be about the same thing. Okay, so the most common of these three is the TNC system, and let's talk about this one and what we are going to actually talk about in detail here. As a base assumption, we are using an already installed electrical system. You have your loads and you have a grid. So the transfer switch is not yet existing, and an inverter is as well not existing. So now you have the plan to be a little bit more independent from the grid operator. You want to have your own solar electricity. You could of course do this in several different ways. You could only use grid-tie inverters. That is the easiest way. You connect your solar system directly to your grid and you use behind the meter electricity. But in this case we also want to be able to be energy independent. So in case of emergency, when the grid goes down, we still want to power our building. So we will initially talk just about to have two choices of input. One is the grid and the other one is our solar inverter, which is an off-grid inverter, a pure off-grid inverter. But we will also talk about what happens if this inverter is not just an off-grid inverter, if it is a hybrid inverter. And we add an automatic transfer switch. The transfer switch can of course also be just a manual one, so that in case you want to switch from one source to the other, you would have to go there and pull on a lever and switch from one side to the other. So there's also the question, which source of power is your primary, which one will be then your secondary. If your solar system is only small, your battery is only small, this will probably be the secondary power, and you will use that only in emergencies when the grid is down. But if you have a big solar array, a bigger battery, you can of course have your solar system as your primary power source, and the grid will only be used when the battery is depleted, when you have maybe several days of bad weather, something like this. As well, important to consider are what is underneath your building in the soil. Like here in my place, my property does not have anything inside the soil. There's no metal pipes, no gas pipes, copper pipes, whatever. Everything what is around buildings is just made out of plastic, so non-conductive. If I want to put another earthing rod somewhere, it will not matter at all. There's nothing to consider other than maybe where the position of the next nearby earthing rod is, because those should be at least 5 meters away from each other, because otherwise they would interact with each other. So now let's start with the most common earthing system, and this is the TNCS system. Right, we have a TN. The first two letters stand for the generator, for the power source, and this means earth and neutral is combined. So if you look at the grid, you have your transformer somewhere, we have a hot wire and we have a neutral wire, and the transformer does have its earthing there, and earth and neutral are bonded. Earth and neutral bonding at the transformer of a grid is standard, so there will always be a earth and neutral bonding, but sometimes, you will see it later in other earthing systems, the utility might not give the okay that this can be used like that. But as long as it is a TN system, this ground and neutral bonding is from a very low impedance, and this will go throughout all the systems and can be used. The speciality of the TNC system is that from your power source you only have 2 conductors. So if you live in Northern America, where you have a split phase, you will have 3, because you will have L1, L2 and the N, but there is no separate earthing conductor going to your property. So this neutral conductor, it is called the PEN, it's a potential earth neutral combined conductor, and this one will be supplied to your building, to your load center. Now there are several ways how the utility, where the utility will split up that one again, but if it's a classic TNC system, you will get only those 2 wires until your load center. So they do it here in Thailand, you will find that almost everywhere like that. Correctly, it is done like this. You are getting 2 wires into your house, into your load center, and the neutral wire will first go to the earthing terminals of your load center, to the PA bar, and from there will be a jumper, neutral jumper to the neutral input of the RCB, and at the output, neutral output of the RCB, that one will go then to the neutral terminals. The L will go straight into the RCB and then will be distributed to the different circuits. So that is the classic TNC. If you open your load center and you find this configuration, then you know that is TNC system. Here in your load center, the separation is done by using then the PE terminals to provide a separate PE to all your devices. So now some countries it is mandatory that the PE terminal bar there, which you have in your load center, does have an extra grounding rod, earthing rod. Every extra earthing rod in the TN system is called an alternate earthing point. These alternate earthing points are very common. They're actually necessary in many cases because there is, with the TNC system, there's one risk. When the PEN conductor is broken somewhere and the live conductor is still intact, the return path of the electricity is broken and the whole system beyond the break is actually set to a high potential. So because that can be a dangerous situation, these alternate earthing points are common and also mandatory sometimes, because they can then, in the case of a broken PEN somewhere from the utility side, that they can then pull down your neutral conductors to ground. So that's why also if there is metal pipes in the ground, copper pipes for gas, whatever, all these will be connected here and connected, bonded to the earth. And of course this also means in the TN system that via those pipes, if you live in the street with neighbors, via those pipes, all those systems, the houses will also be interconnected somehow via the piping. And all this is no problem because neutral and earth is bonded throughout the systems anyway. Okay, what happens now? We are adding our solar system, our off-grid inverter, so we are adding a transfer switch. We can choose either come in via here or via here. If you add your own generator somewhere, so a generator, gas generator, inverter, whatever, you try to keep your installation as it is. And what you do, what you install extra, before the transfer switch, you build up your inverter side exactly the way as the input side of the grid is built up. So as we have an input, two wires, neutral bonded to earth, we have to exactly create the same situation on the inverter side. The inverter, as we have seen in the last video, is in the last two videos, is an IT device. So there is no earth and neutral bonding there. So we have our neutral and live going into the ATS or manual transfer switch, and we need our own earthing rod. We provide earth to the inverter and we bond earth and neutral before we go through the transfer switch. Very important, so that the other side of the transfer switch can stay exactly as it is. Okay, so that was the TNC system. What about the TNS system? So in the TNS system, your electricity into the building is supplied by 3 wires. It does not mean that the earth wire is coming straight from the earthing of the transformer. That side can still be a TNC, but some time before it comes to your load center, the utility will already separate the neutral again and the earth wire again. So you are getting 3 into your property, As long as you have 3 wires coming into your property, you consider it as a TNS system. TNS systems are built up like this. You have your live, your neutral, they are going straight into the RCB, the outputs to your neutral bar, and the lives going to the circuits, and the earth wire is connected to your earth terminals here. And in this case, typically, because you have an extra earth wire coming in, normally you do not need another alternative earthing point, so no earthing rod for that building. And also here still, of course, your pipes, if they are here, will also be bonded here on the earthing bar. So in this case, we have 3 into the transfer switch again. Again, we don't want to change anything on this side. We try to exactly replicate the system as it comes in from the grid. We try to replicate with our solar system here. How do we do that in this case? So we need to change the IT system into a TN system. We need our own earthing rod at the inverter, because our transfer switch will also disconnect the incoming earth from the ground. So we need this time, we need a transfer switch which at least have here for this one-phase system 3 poles. If you live in the United States and you have 2 Ls, you need a 4-pole transfer switch. And this earthing rod here at our inverter, this will now be our main earthing rod for the TNS system. So this earthing rod must provide a very low impedance. And so we have our 3 wire setup also here in the inverter. The inverter is earthed, and we need to bond here neutral and earth before it goes into the transfer switch. And then what comes out is our TNS system, and we can use that as is. Okay, the last system is a little bit a special one. This is the so-called TT system. TT means, okay, we have earth at the transformer, but you see there's an N missing in the system naming. What happened to the earth and neutral bond at the transformer? Well, the earth and neutral bond at the transformer is there, but the utility, by whatever reason, says there is a problem with that. There's maybe not a good enough impedance value at the transformer earthing point. So the utility says you only get my L and my N, and for the earthing the user, the homeowner, is responsible by itself. So that is the second T. The second T is standing for a double earthing. The power source side is earthed, and the load side must be earthed as well. So in this case you are getting your neutral and your hot wire into your house, into your load center. It goes straight to the RCB, and from the RCB again the N goes to the neutral terminal, and the live wire is going to all the circuits. And here it is a must that the property has its own quality low impedance grounding rod, and this one is providing all the groundings, also of course for the pipes if there are some there, throughout the system. how do we add an off-grid inverter to this kind of system? That is actually very, very easy, because we already have this guaranteed low impedance earthing at our property. We can actually use it also for the inverter, because the inverter is anyway at your house and part of the electrical system somewhere near there, right? So we provide L and N through the transfer switch. In this case we need again one which can disconnect also the earthing here, because the reason for that, you will see, is that we of course still have an IT system here, so we need to make a bonding. But we can use already the earth from the house. So this earthing rod at the inverter is not necessary. You can of course make it, but we have to bond earth and neutral here, the input side of the transfer switch. So this is turning the system into a TNS system, right? So the moment we switch over the transfer switch, our system changes from TT to TNS, and it stays like that until you disconnect, until you switch again back to the grid. That's why it's important that this earth is also switched, because then it is switched back into a TT system. What if our inverter is not an off-grid inverter? What if it is a hybrid inverter? So as I said, hybrid inverters are all inverters which are not purely off-grid inverters or not purely grid-tied inverters. They have some features built in that they can switch between modes. So there's two groups essentially of hybrid inverters. One group is those which are typically in their main feature off-grid inverters, and they do have an extra N and L, also AC input, and in case the battery is depleted, they will switch over to the grid. Other type of hybrid inverter would then be the primary grid-tied inverter, and they can, if the grid goes down, then separate from the grid and be an off-grid inverter, so they can give you emergency power. But in our case, I want to kind of look to those sort of hybrid inverters which are primarily off-grid, and when the battery is depleted, they will use AC from the AC input and just switch it through your system. And you might already suspect that if the switching is done, that there might be some sort of a problem. And let's talk about this now. So let's take our TNC system again, because this one is the easiest when it comes to such a switch. Okay, we have our AC in, our neutral in. These are connected before the transfer switch, of course, to the grid, right? So the system here usually runs on your solar. The battery is depleted. The hybrid inverter is making a connection, internal connection, L and N. What does that mean for the TNCS system? Because you can suspect, if there is a switching done on the input side like this, this would of course have an effect on our output side, which might not be intended like this, right? But does that matter in the TNC system? So what happens if these two sides are switched together? Well, as you can see, the neutral side of the transformer, the PAN, is actually now coming from here, and it is bonded here towards our earthing of the inverter. So in the case the hybrid inverter is switching over to AC from the grid, we are adding an alternate earth point into the system, which was not before there. But as we said, in the TNC system, alternative earthing points are common. It's just then another one extra, which might or might not do anything to your system. So no problem. The only change what happened here is we have added an earthing rod into the system, and everything else will just continue fine like that. So in the TNCS system, a hybrid inverter like this will not cause any problems. How about the TNS system? So as well here we are getting a connection to L, to neutral, and these two are switched over when the battery is depleted. So this here, this side is also, we are running on our solar. So the inverter switched over to the grid, and exactly the same thing happened as on the TNCS system. We are coming here again via this bond, another alternative earthing point. So because the grid is anyway also again a TNC or TNS, this will not do anything to the function of our grid connection. We have created another extra earthing point, which will not be the same low impedance as that one at the transformer anyways, so it may or may not do anything in our case, right? So this system can also be considered as absolutely no problem if you use such a hybrid inverter who is switching from one to the other. So but now we have the problem case. The TD system, in this system we do not get earthing from the utility, from the grid. So let's connect the hybrid inverter again to our grid, and the battery is again depleted. We are switching internally over. But what does that mean? Okay, so here now you can see there's the problem, right? If we switch, if this inverter switches to the grid AC input, this is typically done by relays, we are connecting the neutral side of the grid via our bond, earth bond here, because this ATS is now switched through here, to our earthing system of our property. It might not mean much if that transformer is only there for you, your next neighbor is far away from you, you have your own transformer, small transformer, which, as I said, might have an impedance problem only. So if you are the only one on that grid connection, that might not do much, right? Because you are now providing the TN link to that grid connection. But of course, if you are living in a street and you have several neighbors and they're all on that same transformer, you would provide a TN link to each of those houses. And that might not be legal, right? So unfortunately, in the DN system, you have to be extremely careful with the device, with the equipment you buy. This sort of inverter, which is just switching something through, is not possible to be used here. So we cannot use this link here. There are special inverters which do have a feature, an internal bonding relay here, and this internal bonding relay is programmable, and as long those inverters are in the off-grid mode, they close the relay, the bonding relay, and once they come into the bypass mode, they have to open that relay. That can be set, so you have to be really aware of that in this case, in the TT system, you need an inverter with this special feature which has a internal bonding relay. Otherwise, as before, everything stays the same. So this here is the sort of transfer switch I'm using. You have a normal side and a reserve side, and yeah, this can switch automatically. If the normal side goes down, it will switch over to the reserve side, or can also be just turned manually. But in your case, you can of course also use manual switches, which are like knife switches, something like this, which it's just about switching one side to the other, and you have to have enough poles on the switch to also switch all your incoming wires, so which might be, let's say, 2 hot wires, a neutral and a earth wire. For a 3-phase system you would actually need 5 poles. They are not available, but usually when it comes to the off-grid inverters and stuff like this, those are anyway just 1-phase devices, and you would just supply a certain part of your electrical system with your solar power then. Okay, so as I said, use this information as a guidance how you can tackle and analyze your specific individual electrical installation if you want to add a solar system which can make you independent from your grid operator and supply you emergency power as well, or even run your house and the emergency power is coming from the grid. So yeah, so it is highly depending also what kind of equipment you have in your country, etc. You have to be careful, extra careful in the TT system. You don't want to make some unintended bondings which should not be there, especially if you live somewhere in a street with other neighbors. Yeah, that's more or less what I can tell you, and I hope that for some of you this information can clarify a few questions you might have had about earthing systems. So thank you for watching. Please use the comment section if there is something unclear, or maybe I have explained something the wrong way or made a complete blunder anywhere. Otherwise, like the video, please subscribe to the channel. We need much more subscribers. Anyway, I see you next time.